I'm about to be exposed by a number that will tell me if I am actually fit. Welcome to part 2 of Barbells and Braincells, where I explain to you the science behind your workouts, and today you get to come with me to do a VO2 Max test. But before we head in, let's back it up for a minute. We need to make sure that you actually know what VO2 Max is. When we exercise, there are a few ways our body can create energy. I talked about the first two in part 1, and today we're going to talk about the third way. There was the phosphocreatine system, there was anaerobic metabolism, and now we are talking about aerobic metabolism.
When you inhale, you're breathing in oxygen. Duh.
That oxygen that's now in your lungs is going to hitch a ride on red blood cells, and it's going to travel to your muscles or your tissues or other places.
Once oxygen arrives at a muscle, the mitochondria are going to use it to break down carbohydrates and fats and other fuel sources to make energy.
The extraction of oxygen from the bloodstream is called oxygen consumption. Remember that for later. Okay, amazing. We're using oxygen. We're making energy. Great. Wrong. While this method generates a lot of energy, it doesn't happen very quickly. How do we fix this problem? We join a run club. By doing more endurance training, there are physiological adaptations that will make us more efficient at pulling oxygen from our bloodstream. How might one do that, you ask? Well, we develop a stronger heart muscle, meaning we can eject blood more forcefully. We get better at controlling where that blood flow is going. More blood to working muscle and less blood away from things we don't need, like the kidneys. We see increase in the amount of hemoglobin or red blood cells, which means we can carry more oxygen to the tissues, and we make more mitochondria. Going back to our VO2 max test, what we are testing today is how much oxygen my body can consume in 1 minute. If I'm super fit and I have those physiological adaptations we just talked about, I'm going to be able to consume higher amounts of oxygen per minute. At this point, you might be wondering why I look like a cyborg. This mask on my face is how we're going to measure whether I am using aerobic metabolism, utilizing oxygen to make energy, or whether my body is using a different kind of energy system. It's also going to help us figure out how much oxygen my body is extracting. Assuming I'm standing in ambient air, we already know the amount of oxygen I inhale. The other side of the mask measures the oxygen and CO2 I exhale, and we use this to figure out how much oxygen is being extracted by my tissues. As you'll see later on, the mask is then connected to some tubing. It runs over to this computer, and it does a bunch of funky stuff that I don't know the details on, and somehow it gives us our gas concentration measurements. This is called spirometry, and alongside this, we're also going to be measuring blood lactate, heart rate, and relative perceived exertion levels. So of course, first we have to measure all of these variables at rest. Here's me getting my blood lactate measured. I will explain why this variable is important to measure in a second. Now this is where the test actually begins. I'm going to start pedaling, and every 3 minutes my classmates are going to increase the resistance on the bike, therefore increasing the intensity I experience until I can no longer ride this goddamn bike anymore. Heart rate, blood lactate, and RPE are taken in the last 30-ish seconds of every stage. What we expect to see is with increasing intensity, there's going to be a plateau in which my body can consume oxygen. At this point, even though the intensity is increasing, my body is extracting as much oxygen as it can from the blood, and it just can't do anymore. Remember when I said that generating energy using oxygen is very effective, but it's not really all that fast? Well, this is why we take the blood lactate measurements. As the amount of intensity increases, my body is going to need energy faster than it can create it by using oxygen. So it's going to switch to other methods, which you might be familiar with from my last video, anaerobic metabolism. Now, anaerobic metabolism is just that. It is fast at making energy, but it is not very efficient. And it also produces lactate and carbon dioxide as a byproduct. If we do everything correctly, as our VO2 starts to plateau, our lactate measurements should start to rise as well. And that's just extra confirmation that we are switching from aerobic metabolism to anaerobic metabolism. Oh my gosh, that's a lot of yapping. Okay, so how do we actually figure out what my VO2 is from this test? Well, we gotta look at the data. I told you earlier that when we hit VO2 max, we should expect to see a plateau in the graph. These graphs represent absolute and relative oxygen consumption, and it is pretty obvious that there is no plateau in either of these graphs. Thankfully for us, not all hope is lost. Remember those handy-dandy lactate measurements we took? If we can identify lactate threshold 2 on a graph, we can still do a predicted VO2 max. Lactate threshold 2 is a point of high-intensity exercise where lactate builds up in our blood so quickly that our body cannot clear it. This point typically happens when we are working at 80 to 90% of our VO2 max. So if we see that lactate threshold happens at approximately 150 watts, we can look at our VO2 graphs us and figure out our VO2 at 150 watts.
At lactate threshold 2, my absolute VO2 was 1.78 liters per minute, and my relative was 29 milliliters per kilogram per minute.
If we assume lactate threshold happened at 85% of my max,
We can do some simple rearranging of formulas to figure out what my true VO2 max is.
and my estimated VO2 max is totally and completely and maybe slightly under average.
Come on, push. We're done. And then I do want to answer.
Oh my gosh. My quads feel like bricks.
Yeah. You did so good. You did so well. Want me to grab the water for you?
Sure.